Hello everyone, welcome to CamSquad. In this video, we are going to talk about electronic configuration. And by the end of this video, you will have a clear understanding of how electrons arrange themselves in an atom. Let's dive in. So what is electronic configuration? Electronic configuration describes how electrons are distributed in various atomic orbitals. This arrangement determines how atoms interact in chemical reactions and bond formation. For example, when we take sodium atom, it has 11 electrons, and this diagram shows how those electrons are arranged. So these electrons are actually arranged in the space around the nucleus of an atom. Then what is the name given for those orbits, energy levels, or electron shares? So in sodium atom, it is having three electron shares. So for the first shell, it is having 2 electrons, second shell having 8 electrons, and finally the third shell having 1 electron, and these 11 electrons are filled. So according to that, there are energy levels as well as sub-energy levels are present. So atoms have different energy levels. So first energy level, also called as K energy level, and it is having one sub-energy level. And second energy level is having two sub-energy levels. Third energy level is having three sub-energy levels. And whereas the fourth energy level is having four sub-energy levels. So in this table, I have clearly mentioned what are these sub-energy levels. So S, P, D, and F are the four sub-energy levels, and each sub-energy level is having their own shape, and for the S sub-energy level, one orbital, and it can hold up to 2 electrons. And for the P subshell, it has 3 orbitals and it can hold up to 6 electrons. And for the D sub-energy level, it has 5 orbitals and it can hold electrons up to 10. And for the F subshell, it has 7 orbitals and it has 14 electrons. So this is how the electrons are arranged in each sub-energy level. Now let's talk about Spdf notation. So what is Spdf notation? So this method specifies where electrons are located. So when we take hydrogen as the example, so hydrogen is the first element in the periodic table. So it is in first period, first group, you can observe hydrogen atom. So how are we going to write the Spdf notation for hydrogen? So if hydrogen is having only one electron, definitely it should have only one energy level. So this one indicates the energy level. So we know the first energy level is having only one sub-energy level. Therefore, definitely it should be S sub-energy level. So 1 is this superscript. This one shows the number of electron in the S sub-energy level. So it represents 1s1. So this is the SPDF notation for the hydrogen. Now we take another example. Alright. Let's now look at sodium. So we know sodium is having 11 electrons. So what is the electronic configuration of it? So first thing you should know is how many main energy levels the sodium should have. So sodium atom, it should have 3 main energy levels. So then the first energy level, it fills up to 2 electrons and it completes 1s2. Then second energy level, it is having two sub-energy levels. Then the two electrons are filled to the S subshell and it forms 2s2, and the 6 electrons are filled to the P subshell and becomes 2p6, which the total is the 8 electrons, and the remaining 1 electron then goes to the next energy level, which is the third energy level. And third energy level, it can have 3 subshell, but only 1 electron is remaining. Therefore, it goes to the S subshell and forms 3s1. So that's how the electronic configuration of the sodium atom is arranged. So this notation helps us to understand the arrangement of electrons in sodium and its chemical behavior. And now we'll discuss the electronic configuration of the potassium. So potassium, it is having 19 electrons. So now we decide how many main energy levels this potassium atom should have. So it should have 4 main energy levels. So same as sodium, the first energy level holds 2 electrons and it forms 1s2 and 2s2. The other 2 electrons are filling, and then 6 electrons fills to the 2p subshell and making it the 8 electrons in total, 2s2, 2p6. Then the third energy level, it fills 2 electrons in the 3s and it gives 3s, and 6 in the p subshell and gives 3p6, and which the total is 8 electrons. And the last electron goes into 4th energy level, and it forms the electronic configuration, the 4s1. So the potassium's configuration ends with 4s1. So you might wonder, why does the structure shows only 8 electrons in the third orbit when it can hold up to 18 electrons? So answer lies in the energy levels, which means when we take potassium, after filling its third energy level, P sub-energy level, with 6 electrons, the next electron is enters to the fourth energy level. That means it becomes 4s1. So the reason is it has slightly lower energy than the P subshell, because we know third energy level is having S, it can goes up to S, P and D, but that remaining electron is not filling to the D subshell. Rather going to the D subshell, it goes to the next energy level, which is the fourth energy level. So the reason is the energy is slightly lower than the D subshell. So that's why the potassium's configuration stops at 3p6 for the third energy level, with only 8 electrons shown in the Lewis structure. So this pattern reflects the atom's most stable and the lowest energy arrangement. And I hope you guys understood this electronic configuration and how this Spdf notation is written. And this part is essential for understanding bonding, periodic trends, and to understand chemical reactions. So if you guys found this video helpful, like and subscribe to Chem Squad for more chemistry videos.